Hello everyone, this is Jia Chen. I'm here for the Ece6303. This is homework 5, and I will talk about this question first. So this question asks us to get the results of the z. Z is x plus 1. So from the lecture, we know that we can treat it as a signal processing problem. So basically, we just need to use the convolution method to just use based on the distribution of x given x and y to compute this distribution. And for this question, we have one problem. The problem is that this part is a little hard to solve. So it's not the normal. So we like the normal distribution, it's just a square signal. So it's just a one, and it's very easy to compute. And we know the the property of the normal distribution. It's not it's like common normal distribution. So basically, we can write down the convolution of these two so-called normal distribution to get a triangle signal. So this is from the DSP course or some basic signal processing course. So we can use this property to solve this question. So this question is basically just move to the right one part for x, and y keeps the same. So basically what we need to do is just to move this triangle one step forward. So this will be like an intuitive result. So basically I generally give two of this question. So this question is just ask us first to compute, and then based on computation we have the corresponding u, and we can write down to draw the graph of this u. So basically we need to treat u with different scenario, maybe z minus 1 or mu z or something like that. So after that we can get the picture here. So actually if we want to use that in the future, we can remember this property. So this will give you a triangle after two of the rectangular convolution together. Then we can get the result. And if we want to compute the mathematically, actually we can write down the equation and expand it. And we know that some part of it can combine together, and we can get the result, and we will see the result in a few minutes. And after that we can simply get a sequential u. So that's what we need. And I think that's it. If I want to to more graphically, we can treat it as we still treat this x as a function of mu x minus mu x minus 1. But this way it's simplify the computation and simplify the whole image. So basically this is x, and this is this is x, this is y, and what is x plus y is just this line here, but we can have several lines in between. So we need to like to analyze this part and then analyze this part. I will change another color, this part, and then basically like beyond this arrow we will always keep the same, or say that we don't have x and y, we don't have that. So basically the z is 0 after that. So we can separate this question into 2 parts or 3 parts as you have to define that. And then basically we can like to write down different scenario. We have like different p z less or equal than little z, and this is basically just the x plus 1. So z runs from this point here to all the way to here. So this is how we solve the question, and let's see the results of this question. So for this question, firstly, as I said, I just expanded to a two huge uniform function, like multiply together, and then we can like simplify them. Then we can like just based on this formula here to generate this, what we have already said, that this is just a triangle. And we need to remember that we need to like shift one step because we change the x here. So the same idea here, we change the x first, then we draw the picture of the x-y's relationship corresponding to z. Then we separate the situation into 2 parts, less than 3 parts, I think, less than 1, greater than 1, and less than 2. So this is like beyond this scope, then everything is gone. So everything is gone here. Intuitively, it's basically just xy equals to 0 after this point. So z must be 0 because nothing will happen at this point because we don't have z. Okay, so we need to keep in mind, we need to shift 1. And I think that's it. It's very simple. We need to remember the property of the triangle and the rectangular and shift. So this is basically a DSP problem. That's it. Thank you.